Good morning, everyone. I am Subhashni. We are from Polarity Engineering College. As part of the NETRIC Hack 2026, we selected the problem statement resilient multi-master state synchronization over unreliable mesh networks. And the project we did is EtherSync. Ether means if there is no internet, no proper connection. Also, it tries to maintain and synchronization between the data between the nodes. And the team name is Terminators. The team members are Subhashni, Vandana, Reddy Swapna, Yashashwini. Now let's go to the index of this written proposal. These are all the topics we will cover in the below written proposal. And the problem understanding. Imagine if there is no internet, no connection. How can you communicate? Then there our solution comes into the picture. And the statement is how can multiple nodes maintain synchronization state when communication channels are unreliable and lack central coordination? And the key constraints we identify are no TCP availability. So we are working with UDP and high packet loss, network partition, failures, node failures, high latency and jitter, and no central authority, and the real world application. If we implement solution for the problem statement, then that solution can be used in all these applications. Disaster recovery. In the rescue team can to connect with higher officials or victims without any cellular infrastructure, that is no internet. They can you connect using our solution. And the military communication, the persons can communicate directly without any central person. And the rural health care, in the rural areas there is no internet. To maintain the patient record synchronizingly, we can use this. And IoT IoT clusters also, without any cloud connectivity also, we can work while using the solution. And what is our success criteria means to achieve eventually consistency, we will take sufficient amount of time and try to synchronize the data between the nodes. And we prioritize availability and partition tolerance over immediate consistency. And this architecture is it consists of 5 layers, that is application layer, sync layer, reliability layer, transport layer, and peer management. And we will see the workflow. That means the transport. How we will transport means by using UDP, which is unreliable. And next, peer management. It will check who is online. Next, through reliability, it will check by ensuring that there is no loss of messages. And sync, it will find the differences, and those which have differences, it will send to the data to those nodes only. And the application layer stores the data. And we will also follow some mechanisms to achieve reliability at the application level. And coming to the UDP protocol design, the protocol contains various fields that was mentioned here, and every field has some purpose which is used for communication between the nodes and maintain synchronization. And these are the message step taxonomies for the protocol design. You can observe the name, purpose, and response clearly mentioned there. And why our protocol is superior means here we are using here to checksum, which catches corruption and used for error correction also, and sequence number for loss detection reordering, and those are the others. And how can we achieve reliability? Because as we said, we are using UDP. UDP itself is unreliable. How can we achieve reliability means we thought to use the reliability at the application level. So we used some techniques, that is packet sequencing. That means if there is any gap in the sequence number, it thought it was a loss and resends. And the acknowledgement protocol, it was 3 times. If the receiver sends acknowledgement immediately, if the receiver didn't get any message, he sends negative acknowledgement. And the selective retransmission and flow control, these are the techniques we follow at the application level to maintain reliability. And coming to the state synchronization strategy, that we need to maintain synchronization between data. How can we achieve this means by using vector clocks. These vector clocks know where the data came from and when the data came from. So we can achieve this. And if there is any conflicts between them, means if the same data was updated at a time by 2 nodes, then how can we break the rule? Break means, that means tiebreaker means we use a timestamp there. Higher timestamp means and lower also modified by the higher timestamp node. And the merge strategy. And next one is gossip protocol. It is like just how a rumor is spread fastly, same mechanism. In this gossip protocol, a node selects a few of the neighbors and it transfers data to those, and those will select another neighbors and transfer data to the nodes. Like this, within less time, the data is transferred to all the nodes within the network. And next one is Merkle trees. Merkle trees means it can't it in this it won't send a complete data to the nodes. It will check the data which is not matched. Only those data will be sent. Save time and memory. And the comprehensive failure handling means here we are achieving comprehensive failure handling by using the mechanisms here to heartbeat, gossip, and RTP. And the heartbeat failure detection means for every 3 seconds it will receive heartbeat. If it doesn't receive for 10 seconds, it suspect it is a failure. If it doesn't receive for 30 seconds, it think it is definitely failure and remove from the active peer list. And node recovery means if any node was crashed and it can again rejoin by using rejoin protocol and can maintain synchronization automatically. And network partitioning handling. These are the some methods we use it for achieving the synchronization. And coming to the system design and modularity, this is the system design we are following for our solution. And trades off and limitations, we can observe consistency level. We are achieving eventual consistency. And conflict resolution, we are solving using vector clocks and timestamps. And security, we are not providing as problem statement didn't suggested. And the scalability, it is designed for small to medium networks. And we can enhance this by using hierarchical gossip protocol if needed. And the clock synchronization memory overhead. And the testing and validation strategy, we are using unit testing and integration testing. And coming to the conclusion, and this ether sync is theoretically sounded, and we can achieve this eventually consistency with the strong mathematical guarantee we are using gossip protocol, Merkle trees, and vector clocks, which plays an important role under a strong foundation. And thank you for giving this opportunity.